In 1977, 85% of Daphne Major's finches died. No researcher has fully explained how fast the survivors changed. Their beaks grew roughly 4% deeper within a single generation, a shift textbooks predict should take thousands of years. Two biologists, Peter and Rosemary Grant, were standing on that island measuring it as it happened. Over the next few minutes, we'll move through droughts, shrinking lizards, and volcanoes still actively erupting, building toward one case, confirmed decades later through genetic testing, that even the researchers who found it did not expect to see proven in their own careers. The Galapagos Islands are usually remembered for a 5-week visit Charles Darwin made in 1835, sailing aboard a survey ship called the Beagle. Darwin himself almost missed the pattern. He didn't carefully label which island each of his finch specimens came from, and it was other naturalists back in England who later worked out that beak shapes tracked cleanly island by island. The more remarkable scientific record from these islands, though, wasn't made by Darwin at all. It was made more than a century later by two researchers who spent over 4 decades returning to the same small island, year after year, to measure the same wild birds by hand. That fieldwork is now considered one of the longest continuously running studies of evolution ever conducted anywhere on Earth. And unlike Darwin's brief visit, it produced numbers, not just impressions. Here's what we actually know about how it started. Peter and Rosemary Grant first arrived on Daphne Major in 1973, expecting to spend a single season there. Daphne Major has no freshwater source and no permanent settlement, so every visit meant hauling in their own supplies and camping in a small tent wedged into volcanic rock. They ended up returning almost every year for more than 4 decades, individually tagging thousands of finches with numbered leg bands and measuring the depth and length of every beak with hand calipers, often down to fractions of a millimeter. Some evolutionary biologists argue this one field study did more to demonstrate natural selection in action than anything Darwin personally observed during his own visit. A claim that still generates pushback among historians of science who feel it undersells what Darwin accomplished with far less data. Officially, natural selection is described in textbooks as a process too slow to observe within a human lifetime. That's not what happened on this island. The event that made the Grants' names in evolutionary biology happened in 1977, when a severe drought hit the island. Rainfall almost stopped, small soft seeds ran out, and roughly 85% of Daphne Major's medium ground finches starved within a matter of months. What remained on the ground were the large, spiky seeds of a plant called tribulus, tough enough to require real force to crack open. The birds that survived were disproportionately the ones with deeper, stronger beaks, the only ones capable of cracking those large, tough seeds that were still available, while smaller beaked birds simply couldn't break in. When the population recovered, the average beak depth had increased by close to 4% in a single generation, a change captured on paper, bird by bird, by researchers who were there to record it as it happened. Compared to what's coming, this is still the easy part of the story. That shift did not hold in one direction, though. In the early 1980s, unusually heavy rain linked to an El Niño event flooded the island with small, soft seeds again, and the advantage flipped almost immediately. Birds with smaller, shallower beaks suddenly outcompeted their larger relatives, and within roughly a decade, the population's average beak size had shifted back the other way, essentially undoing the drought selection pressure. Officially, evolution is described as a slow, one-way accumulation of change, something that happens over geological time, not weather cycles. What doesn't fit is that this particular population reversed course twice within a single human lifetime, in opposite directions, and researchers were watching both times, with the measurements to prove it. And that's not the strangest part of what Daphne Major had to show them. Picture standing on that beach in 1977, watching finches drop by the thousands during a drought with no end in sight. If you'd been standing there, would you have guessed you were watching evolution being written into a wild population in real time? The Grants didn't know either, at first. The pattern only became clear once they'd spent years comparing their measurements season over season. What convinced them wasn't one dramatic season, It was watching the same swing repeat, drought after drought, across more than 4 decades of fieldwork. But beak size wasn't the only place these islands were quietly rewriting the rules of biology. A short boat ride from Daphne Major lives a species found nowhere else on the planet, the marine iguana, the only lizard on Earth known to forage in the ocean. Darwin himself described them as clumsy and hideous-looking when he encountered them in 1835. And yet, these are among the most specialized reptiles ever documented. Marine iguanas dive along the rocky shorelines of islands like Fernandina and Isabela to graze on algae growing underwater, then haul themselves back onto black lava rock to warm up in the sun before their body temperature drops too far. Because seawater and algae load their bodies with excess salt, marine iguanas evolved a specialized gland near the nose that filters it out, which they expel in a sharp, sneeze-like burst, sometimes coating their own heads in a fine crust of salt. It's a wholly reptilian solution to a problem no other lizard lineage has ever had to solve. That should have been the strangest thing biologists found about this species. It wasn't. Researchers studying marine iguana populations during El Niño years documented something that shouldn't happen in an adult vertebrate: the lizard's own skeletons shrinking. During El Niño events, warm ocean water kills off the algae marine iguanas depend on, and individuals that were tagged and tracked over multiple seasons were measured losing a meaningful percentage of their body length as their bones physically reabsorbed material to survive the famine. This wasn't a case of the animals simply losing weight or muscle mass, which would be unremarkable. Their actual skeletal length, bone by bone, got shorter. When food returned in following seasons, the same tagged individuals were measured regrowing, lengthening back toward their original size, something researchers had assumed was essentially impossible once a vertebrate reaches adulthood. If topics like this, documented biology that reads more like science fiction than field notes, are the kind of thing you come back for, this channel covers a new one roughly every week. That's not the detail this video is building toward, though. The more paradoxical fact is still ahead. What researchers still can't fully settle is the exact mechanism behind that reversible shrinking. Whether it's a stress response, a metabolic emergency measure, or something closer to controlled bone resorption seen in a few other species under extreme starvation. No one disputes that the shrinking happens. It's the how, precisely, that causes disagreement among the biologists who studied it for decades. What do you think allows a full-grown vertebrate skeleton to shrink and then rebuild itself on command? Leave your theory in the comments, because the researchers studying this are still working it out too. Go back to that 4% shift in beak depth from the start of this video, because the same island chain has another population worth measuring against it. On the upper slopes of Wolf Volcano, on Isabela, there's a land iguana with pink and black skin found nowhere else in the archipelago, and nowhere else on the planet. Local guides had noticed it for years, but it wasn't formally recognized as its own species, the pink land iguana, until 2009. More than 170 years after Darwin's visit. Fewer than a few hundred individuals are thought to survive, confined to a single volcanic slope. This is now the 3rd documented case on this list of a Galapagos species being defined, or redefined, by direct field measurement rather than assumption. And it will not be the last one. The pink land iguana's entire known habitat sits on Wolf Volcano itself, on Isabela, a volcano that is still very much active. Wolf erupted in May of 2015, its first eruption in over 3 decades, and then again in January of 2022, sending an ash plume thousands of meters into the sky above the very slope the pink iguanas call home. Park officials confirmed on both occasions that the lava flows moved away from the iguana population, rather than through it. But the margin for that kind of luck is not something conservationists can count on indefinitely. A short distance away, La Cumbre, the volcano that forms Fernandina Island, has erupted repeatedly in recent years, including documented eruptions in 2009, 2017, 2018, 2020, and again in 2024, sending lava flowing down toward the coastline each time. On Isabela, Sierra Negra erupted in 2018 after roughly a decade of buildup, with lava traveling several miles from the vents and reaching the coast within days. Officially, The Galapagos are treated as a fixed, ancient backdrop for evolutionary study, a stable stage the animals happen to live on. The problem is that the stage itself keeps moving. Sometimes in the same years, researchers were out counting finches and iguanas. Try to picture that yourself. Measuring beak depths on one island while a volcano on the next is actively repaving the coastline. All of that volcanic instability turns out to matter for one very specific reason. Coming up next. All of this, the droughts, the shrinking lizards, the erupting volcanoes, sets up the single most paradoxical finding to come out of Daphne Major. In 1981, a large male finch turned up on the island that didn't belong to any of the resident species, noticeably bigger than the local birds and singing an unfamiliar song. Genetic testing years later identified him as a stray from a completely different island, over 60 miles away, blown or carried far outside his normal range. He mated with a resident female of a different species, which itself is unusual, and their offspring survived and bred successfully. By the third generation, his descendants were singing a unique song, distinct from either parent lineage and breeding almost exclusively with each other, functionally isolated from every other finch population on the island. A genomic study led by researchers including Sangeet Lamichhani, working with the Grants, confirmed the new lineage's distinct genetic signature years afterward, and it's now informally known among researchers as the Big Bird lineage. Officially, the formation of a new species is described as a process spanning many thousands of generations, built up gradually as populations drift apart. The complication is that this lineage became reproductively isolated within two. That fact alone raises a question even the researchers who documented it haven't fully settled. Whether the Big Bird lineage counts as a fully established species in the strictest technical sense is still argued among evolutionary biologists, because the standard rules for defining a species were never built around watching one form in real time. Imagine being the researcher who realizes the birds you've been measuring for years just split into something new in front of you. Where do you land on it? New species? Or an unusually fast case of interbreeding that hasn't run its course yet? That's a question researchers studying Daphne Major are still debating, and it's one this video won't settle for you. Start back where this video did. 85% of Daphne Major's finches dying in a single drought year, and their beaks measurably changing shape in response. That number is proven, recorded, published, and repeated across more than 4 decades of continuous fieldwork by researchers who were physically present for nearly all of it. What remains genuinely open is how far that kind of rapid change can go. Whether a lineage like the Big Bird settles into a permanent new species, or eventually blends back into the populations around it, and how reversible skeletal shrinking in marine iguanas actually works at a cellular level. The Galapagos are not a fixed monument to something Darwin noticed once in 1835. They are an active laboratory, still producing new, contested, unresolved data on the same islands where the youngest volcano in the chain erupted as recently as 2024. Somewhere on Daphne Major right now, a new generation of finches is being measured, and no one, not the researchers who inherited the Grants field notebooks, nor anyone watching this, yet knows which direction their beaks are about to move.